All right, so question number one says the students state the principle of conservation of momentum. So how you can write it that in an isolated system. So what is an isolated system? It is a system which is free of external forces, which is free of any unknown resultant force. So in an isolated system, the total momentum, the total momentum before collision is equal to the total momentum after collision. So this is known as law of conservation of momentum. So it's a pretty statement which we have already studied during our lessons. All right, question says the ball X and ball Y. There are two balls, one is ball X and the other one is ball Y. They are traveling along the same straight line in the same direction as shown. So एक का mass है, let's say one of the mass one is 400 and the other is having a mass of 600 grams. Initially, this one is moving with a velocity of 0.65, the second one is moving with a velocity of 0.45. Okay, ball X catches up and collides. After collision, X move with the velocity of this. So let's say it is V1 and this V is to be found for the velocity of ball Y. So what question is asking here? Find the total initial momentum of the two balls. So total initial momentum means it's the total momentum before collision. And this is going to be found as what? M1 U1 plus of M2 U2. So how will this be found as? What is the M1? M1 is going to be the mass, and though we have to find the momentum in our SI units, so it will be equals to क्योंकि 400 grams है, so this is to be converted into 0.4 kg. It is to be converted into kg. So how to convert into kg? Divide by 1000. So first mass will be considered as 0.4 and its velocity u1 is 0.65 plus of the mass of 2 is around 0.6 kg into its initial velocity is 0.45. So when this all is going to be multiplied, we will be ending up with an answer of 0.53 Newton second. So our total momentum will be 0.53 Newton second. So it has just asked the total momentum before collision. Next it says you have to find out the velocity. So जब वो velocity कह रहा है तो here as the collision is occurring, so whenever a collision is occurring we will be using the law of conservation of momentum. So what does the law of conservation of momentum says? M1 U1 plus of M2 U2 is equals to M1 V1 plus of M2 V2. So एक चीज आपने देखनी है, the direction of each ball is towards right. It means all the momentums are going to be positive. So all the momentums are positive. Yes, all the momentums in this whole relation is positive. So let's begin with the mass one. How is the mass one? Mass one is zero point 0.4. So it will be written as, so we have just found this initial momentum. So let's replace this initial momentum with a value of 0.53 as found in the previous part, which will be equals to mass 1. Mass 1 is how much? 0.4. And what is the velocity with which it is moving afterwards? This velocity is 0.41. So this will be written as 0.41 plus what is the mass to 0.6 into V. V is to be found. So the mathematical expression which is going to be found after solving all of this for V, it will be equals to 0. This V will be equals to 0.61 meter per second. This is how this V will be found. Yes, any problem to any student? Is this fine? I guess it is a pretty simpler question. It won't be hurting much. Yes, student, do let me know. Shall I move on? Yes, people, speak up. Am I audible enough to you people? जी प्लीज बोलिए. Shall I move on or shall I wait?
Yes.
Yes, sir. Move on.
Okay, so let's discuss the next part. Next part, it says find the total initial kinetic energy of the two balls. So what's the formula of initial kinetic energy? Initial kinetic energy is equals to half mv square. This is the formula for the kinetic energy. So initial kinetic energy means initial kinetic energy of first ball plus initial kinetic energy of second ball. So this will be equals to half m1 u1 square plus of half m2 u2 square. So how this can be written? We can take half as a common from both, and when a half is taken as a common, so this will be written in what way? As 0.4 multiplied by 0.65 square plus of what is mass 2? Mass 2 is 0.6 into 0.45 square. So this whole expression, when it is going to be solved, so we are going to end up with the total energy as 0.15 joule, right? So this is how we are going to find out the total initial kinetic energy of the two balls. Is this fine?
Yes, sir.
Okay, next part. Next part says explain how you would check whether the collision is elastic. So we need to check whether the collision is going to be elastic or inelastic. So yes, guys, the answer to this will be the total kinetic energy. The total kinetic energy before collision should be equal to should be equal to total kinetic energy after collision. Okay, guest, bye bye. So guest, you are being eliminated from the group. Thank you very much. So total kinetic energy before collision will be equals to total kinetic energy after collision. Okay, next it says this question is pretty interesting. This question says use Newton's third law to explain why during the collision the change in momentum of x is equal and opposite to the change in momentum of y. Yes, guys. Uh, as per Newton's third law of motion, so what does the Newton third law of motion says? That the force which will be exerted by x. So let's say this is my ball x and this is my ball y. So during collision, when they are going to collide, and after collision, they are going to get separate, right? So they're going to separate might be like this. Okay. So the force which is going to be exerted by x will be equal and opposite to the force exerted by y on the x. And we are pretty aware that force is equals to change in momentum over time. So both of these forces, like force x is equal and opposite to force exerted by y. So as force is equals to rate of change of momentum, so in the same amount of time, the if force exerted by x is same as y, so change in momentum will be same as exerted by x on y. So what we are going to write over here for this specific answer, you are going to say the forces on two bodies, x and y, forces on two bodies, forces on two bodies, x and y are equal and opposite. The forces on two bodies X and Y are equal and opposite. And force is equal to rate of change of momentum is equals to rate of change of momentum. So as the forces are equal, so in same time, so in same time, the change in momentum, the change in momentum of X is equal and opposite to change in momentum of Y. ठीक है, this is all related to this formula F is equals to delta P over T. So force एक सेम टाइम में किसके इक्वल है, चेंज इन मोमेंटम के. और न्यूटन का थर्ड लॉ क्या कहता है, जो फोर्स एक्स ने लगाई है वही फोर्स वाई भी लगाएगा, बट ऑपोजिट डायरेक्शन के अंदर. तो अगर फोर्सेस सेम हैं तो चेंज इन मोमेंटम भी क्या होगा, सेम होगा. एंड चेंज इन मोमेंटम, फोर्सेस अगर ऑपोजिट डायरेक्शन में तो चेंज इन मोमेंटम भी ऑपोजिट डायरेक्शन में होगा. So this is how we are going to answer this. So Newton's third law of motion says force exerted by one body on another body is equal in magnitude and opposite in direction to the force exerted by the second body on the first body. Is this fine? Shall I move on?
Yes, sir.
Okay, now open question number 5. The question number 2 is pretty simple. ये आप खुद करेंगे. This is your homework. This is easy and it can be solved by you simply. So next question is okay, this is related to moments. So in this lesson we are only discussing momentum questions. हमने कल मोमेंट के सवाल किए हैं, तो इट इज प्रीटी सिंपल. आप इसमें सिंपल लॉ ऑफ कंजर्वेशन मोमेंट्स को अप्लाई करोगे, प्रिंसिपल ऑफ मोमेंट्स को. ओके, ये अभी एनर्जी वाला कॉन्सेप्ट है, काइनेटिक एनर्जी का. दिस येट टू बी स्टडीड इन द चैप्टर ऑफ काइनेटिक एनर्जी. So for the time being we are just skipping. Come to question number 5. Question number 5, what is present in question number 5? We are just going to disclose it. So everyone, please see question number 5. What is there? Let's see how we are going to discuss this question. So question 5 says that there is a ball of mass 150 grams. It is on rest. It is at rest on a horizontal floor as shown in figure 3.1. Question says calculate the magnitude of the normal contact force from the floor acting on the ball. All right. So very first thing, we know this is at rest. So this ball is experiencing two forces at the moment. One is weight and other force acting on it will be the normal force, upward force, right? So it is saying the normal force find करनी है और ये rest पे है. So we know normal force will be equals to the weight of the ball, and weight of the ball is found in what way? W is equals to mg. So W is equals to mg. Mass is 150 grams. So we need to convert this mass into kg. So mass is 150 divided by 1000. So this will be equals to 0.15 kg. Mass will be how much? It will be 0.15 into 9.81. So when this will be multiplied, our answer will be roughly equals to 1.5 newtons. So this is going to be the force, normal force. Question 2 says explain your working in A. So you are going to say as the ball is at rest, as the ball is at rest, the resultant force will be zero. The resultant force is zero. What it means, the upward force is equal to downward force. Because the ball is at rest, so the resultant force will be zero. Upward force will be equals to downward force. Hence, normal force is equals to weight. Hence, the normal will be equals to weight. This is how you are going to explain it for 1 mark. Okay, moving onwards to next question. Question number part B. Part B says the ball is now lifted above the floor. So it has been taken to one state of a floor and it is being dropped from here. So it falls vertically as illustrated in figure 3.1. So the 3.2. So this is 3.2. It hits the floor and it rises back upward, right? So ball is falling downward. It is going to hit the floor. It is just before the contact and after contact, it will be moving back with 2.5 meter per second. So just before contact with the floor, the ball has a velocity of 6.2 and the ball bounces from the floor and its velocity just after losing contact with the floor is 2.5 upwards. The ball is in contact with the floor for 0.12 seconds. Now let's state Newton's second law of motion. So we studied the Newton's second law of motion. What does this law says? The resultant force is equal to rate of change of momentum. The resultant force is equals to rate of change of momentum. This is known as Newton's second law of motion. Now question says calculate the average resultant force on the ball when it is in contact with the floor. So we know the formula for finding out the force is what? It is change in momentum over time. F is equals to delta P over T. So let's move back. Let's find out delta P first. So delta P will be found in what way? Delta P will be found in this specific way. We are given with the mass. This is 0.15 kg. So delta P कैसे find होगा? When it is moving downward, let's say it is positive. When it is moving upward, it will be called as negative. So delta P आपके पास क्या आ जाएगा? Mass into final velocity minus of initial velocity. So let's write it down. So change in momentum will be equals to how much? It will be equals to mass. Mass is 150 grams for this ball. So this will be equals to 0.15. And what is the final velocity? It is the velocity when it is moving upward. So this is minus of 2.5 minus what is the initial velocity? Initial velocity is 6.2. It is 6.2. So altogether, your change in momentum will be what? When you are going to solve it, your change in momentum will be appearing as 1.305. It will be 1.305 Newton second. And how we are going to find out the force? The force formula is change in momentum over time. Time is given to us over here that it touches into 0.12 seconds. So this will be equals to what? The force will be given as 1.305 whole divided by 0.12. And when we are going to solve it out, this is roughly equals to 11 Newton. The magnitude of force will be 11 Newton and direction is upwards. Why the direction is going to be upwards? Because we have taken the upward motion as negative. So our force appearing was what? जो हमने force निकाली, that force was also appearing as negative because the delta P was appearing as negative. So this is the reason the direction of force will be taken as upwards. And question says, state and explain whether the linear momentum is conserved during the collision. So you are going to say yes, the momentum is conserved. Yes, the momentum is conserved as the total momentum before collision is equal to total momentum after collision. Please, as an artist, stop doing this. I will remove you from the group. जी हफ्सा अहमद why did we take upward as negative दो बेटा जब अगर वो डाउनवर्ड डायरेक्शन में आ रहा है तो हमने डाउनवर्ड पॉजिटिव लिया ना तो वेक्टर है वेलोसिटी अगर डाउनवर्ड पॉजिटिव कंसिडर करूँ तो अपवर्ड वेलोसिटी मेरी क्या कंसिडर होगी नेगेटिव कंसिडर होगी ठीक है that is why we have just taken it as negative. So momentum is going to be conserved as the total momentum before collision will be equals to total momentum after collision.
Sir Nasir, I have a question.
Yes, please ask.
So how do we know that the total momentum before collision is equal to the total momentum after collision? Because we didn't calculate it, did we?
Okay, in such type of questions, whenever it is being like forward, so when it is being dropped, none of the statement is there that there is some air resistance or there is some external resistive forces and so on and so forth. So it is being always understood whenever any sort of collision is going to occur. Whenever there is a collision occurring in the absence of resistive forces, in that specific cases, the total momentum before collision will always be equals to total momentum after collision, right? It is just a way of asking the law of conservation of momentum in an alternate way.
Okay, thank you, sir. Nasir.
Okay, moving up to the next question. So the next question which we are going to discuss is going to be question number 8. Guys, come to question number 8. Okay, this question is something related to pressure. We have not studied it, so we will be doing it later. Next question number is question number 7. Alright, this question number 7 is again related to density and the stuff like upthrust. So for the time being, we are just skipping this question. So come to question number 8 quickly. So question number 8 says that state the law of conservation of momentum. Guys, I'm telling you, in a meanwhile, might be this session in 9 minutes, it is going to be over. So I request each one of you to please re-log in back because the questions which we are going to discuss in the second session, they are pretty very important. They are of very high importance. So you can just understand that the level of their importance. So I request कि इसके बाद जो session होगा उसमें आपने दोबारा re-login करना है. Do not skip the session. So again, question number 8 says state the law of conservation of momentum. So we have already studied its multiple statement that in an isolated system, the total momentum before collision is equals to total momentum after collision. Or you can say that in an isolated system, the momentum lost by one body is equals to momentum gained by another body. or in an isolated system, the total momentum of the system remain constant. So whatever word you like, you can just choose it for your wordings. So I'm pretty interested into solving in the two-dimensional momentum, the questions related to 2D momentum. So let's see, it's a part B. There are two particles. One of the particle is A, the other particle is B, and they are going to collide elastically. And when they will be colliding elastically, one will be moving this way, the other will be moving this way, as illustrated in figure 5.1. So the initial velocity of A is 500 meter per second in the x direction, and B is present at rest. So the direction, the B is present in a state of rest. The question says the velocity of A after the collision VA is at 60 degree to x direction, and velocity of B after the collision at 30 degree to the horizontal. The mass is considered as 1.6 into 10 power minus 27. Each particle is having this much mass. Question says what is meant by particle colliding elastically? Again, you can state here two multiple answers. Like you can say that a type of collision in which none of the energy is wasted in the form of heat, or you can say for this specific question like the total kinetic energy before collision, the total kinetic energy before collision is equals to total kinetic energy, total kinetic energy after collision. So total kinetic energy before collision will be equals to total kinetic energy after collision. The question says calculate the total initial momentum of A and B. So we are going to find out the total momentum of A and B. So we know the ball B is at rest, but A is moving. So if ball A is moving, we are just going to take its momentum, and it will be written as what? It will be written as m1 u1 plus of m2 u2. So what is the mass of one? The mass of one will be 1.67 into 10 power minus 27, and u1 will be considered as 500 plus. The second one is at rest, so its velocity will be 0. So if you are going to multiply it, your momentum will be nearly equivalent to 8.4 8.4 into 10 power minus of 25 Newton second. So this is how your total initial momentum of A and B is going to be found. Moving onwards, next it says state an expression in terms of MVAVB for the total momentum after collision. First in X direction, let us say in Y direction separately. Okay, I can go back. So total kinetic energy before collision will be equals to total kinetic energy after collision. So m1 u1 plus m2 u2, this will be equals to 1.67 into 10 power minus 27 into 500 plus of 0, and this will be equivalent to this. Shall I move on? Okay. So moving onwards to the next part, state an expression in terms of m, va, vb for the total momentum of A and B after the collision. So first you have to find, now we are going to discuss, so I taught you this thing during the lessons that whenever we are discussing two-dimensional momentum, we are going to discuss the momentum along x-axis separately and along y-axis separately. So let's see what will be the momentum of this ball A after collision. So horizontally, its momentum will be written as mass of A, mass of A into velocity of A cos of 60 degree. Likewise, and the momentum for this ball B will be written in what way? Mass of velocity B cos of 30 degree. This is how we are going to find out the components of the momentum along horizontal. And what will be the components along vertical? It is mass of velocity A sine of 60 degree. And what will be the component of the momentum along vertical? So it will be for vertical, this will be written as mass of VB sine of 30 degree. So this is the way how we can just can divide the two-dimensional momentum into its components. Okay, अभी हमने बात करनी है along x-axis. So in x-axis, and this is the total momentum of AB after collision. So this will be written as what? M VA. It is cos of 60 degree plus momentum of second MVB cos of 30 degree. So this is how you are going to write it down. Is this fine? Next is in the y direction. So what you are going to, how you are going to write it down in the y direction? So one of the momentum is upward, the other momentum is downward. So you will be writing as MVA sine of 60, MVA MVA sine of 60 minus of MVB sine of 30 degree. So this is how we are going to use for the y-axis direction. So you may see the components likewise. So it's a 1 minute. The in 1 minute this session is going to expire. I request each one of you to reconnect again. Yes, we have subtracted because the direction is opposite. Vertical upward इसका momentum upward है and this one is having a downward momentum. Yes, in the marking scheme it is saying add कर दें वो incorrect लिखा हुआ. You can also estimate on your own from here as well कि it can't be added. इन दोनों को आप plus नहीं कर सकते. They are going to be subtracted.